Hey guys, welcome to another episode of Crimes Notes. Today we are actually going to be finishing up our lessons over exponent review. I'm slowly learning that I'm glad I didn't try to go through the entire thing at once because it actually seems that you guys were struggling with this a little bit. So this time we're going to be talking about two different rules, the negative exponent rule and the zero power rule. So this is kind of the conclusion of all of our exponent rules. So the first thing we're going to look at is the zero power rule, and that's because this one is kind of the easiest. When any term, so this is going to be term, is raised to the zero power, the answer is 1. That's it, okay? So if you notice, I've kind of given you two examples in here. Just a to the zero power by itself is 1. And again, it wouldn't have to have these parentheses, even if it just looked like this. A to the zero power is 1. What if we had 3x, the whole thing raised to the zero power? Well, it doesn't matter, it's 1. What if you had 5.2x to the 23rd y to the negative 5th to the zero power? It's still going to be 1. So the zero power abridged version down here is that anything raised to the zero power equals 1. That's it. Now, I want to kind of show you why it equals 1. So if you notice, I kind of put some different things up here. Well, what this actually is, or what you can kind of imagine, is that in front of both of these is a 1. So if I take 1 and I multiply it times 3 squared, that is times 3 times 3, we get 9, which is the same thing as 3 squared, right? 3 squared is 9. So then if I take 1 and I multiply it times 3 to the first power, that just means there's only one of them, we get 3. So then if I'm looking at 3 to the zero power, that essentially means I'm taking 1 and I'm multiplying it times nothing, right? There's nothing there. There's 0 3s. So really, I just have 1. And that's why anything to the zero power is equal to 1, okay? So if we ask for the expanded version, this is what the expectation would be. So let's go ahead and look at our practice problems and notice that we want to simplify and then give an answer. Well, most of these are going to be pretty simple. So here, if I do 2 to the zero power, we can't really simplify anything. The simplify would be 1, and the answer would be 1, okay? But what about if I had something that looked like this, okay? So this 4 times c squared to the zero power. That would be, and it looks like I'm in the exponent, and of course it looks like the baby is crying. Hold on just a second. Sorry about that, guys. Never fails, right? So I would have 4. She's crying. I'm doing my video, but just grab the monitor. I'm just gonna have to, they can either deal with it or, so I've got 4 times, right? And then c squared raised to the zero power. Well, if we use our power to the power rule, 2 times 0 is 0, right? So I still have the zero power, which is just 1. So then 4 times 1 would just give me 4. So that would be our solution, okay? So I'm going to go ahead and go down here to the bottom one. And I guess it's an exponent again there and bring it down. So now I have negative 2x squared. So I'm going to leave that part. Again, remember we're going to highlight and do control period. And then we're supposed to multiply. And I'm going to copy and paste the dot. And then we have this whole thing raised to the zero power. Well, if I would distribute, 3 to the zero power is 1. 5 times 0 is 0, so this is still to the 0 power, which means that whole thing that's in parentheses is just 1. So essentially, I'm multiplying negative 2x squared, so this whole thing, times 1. Well, if I multiply that whole thing times 1, I just get the same thing, negative 2x squared. Okay, so again, anything raised to the 0 power is 1, so you can imagine just replacing that whole part with 1. So that leaves a couple of them for you to do on your own. All right, so now let's look at the negative exponent rule. This one is a little bit different, and I remember a little ways back we talked about how we had a negative exponent and we didn't do anything with it. That's actually not allowed. You have to get rid of negative exponents when you're simplifying, but we weren't ready for that. Now we are. So to fix a negative exponent, you are going to move the base that has the negative exponent to the opposite part of the fraction. I can't type today. To the opposite part of the fraction, and then you're going to make the exponent positive. I don't know why I just said that. So again, we're going to move the base with the negative exponent to the opposite part of the fraction and make the exponent positive. Now, I'm going to have to alter this because obviously it jacked up my examples down there. So I'm going to try to make it a little bit smaller so that it fits on that one line. Okay, so here's the examples. Man, I'm having a hard time today. A to the negative m. Notice we moved the base down to the bottom because originally it was on the top. And then I changed the exponent from a negative to a positive. So what if I had 1 over a negative exponent? Well, basically I moved it to the top. So now notice this is in the numerator, and I made the exponent negative to a positive. So the abridged version, we're going to move the base to the opposite part of the fraction, and then we're going to make the exponent positive. So what if I had x to the negative 5th? Well, notice it's in the numerator because it doesn't have a denominator. It's in the top of the fraction. So in the top now, I would just have to put a 1 as a filler, and then I would move that base, which is an x, into the denominator, and then I would put the exponent, but now instead of being negative, it would be positive. So then what about if it looked like this? Well, now I've got the base with the negative exponent in the bottom, so I would need to move it to the top, and then I would need to make the exponent positive. Okay, so let's look at some real world examples here. Again, I am going to go down and do I guess I might as well do this one because it was already done for you, but I didn't mean for it to already be there. I think I was just making sure that it was going to work. Okay, so if we have 3a to the negative 4, what I want you to realize, or the way to see this, is as two separate terms. I have a 3 and an a to the negative 4th. So the base that has the negative 4 is just the a. It's not the 3 and the a. So I would end up leaving the 3 in the numerator. I guess I need to center these. I'm not really sure. I guess when I deleted stuff, I messed it up. Story of my life today. I got to move this down so I can actually center it. There we go. So I leave the 3 on the top. Golly. And then I would move the base to the bottom. So this would be a. And then I change the exponent to a positive. So then this would be a to the 4th. Now that would be the simplified version. And of course, this would also be the same because we can't really do anything with that. We can't divide 3 by anything or things like that. So the simplify and the answer would be the same. Okay. All right, so let's go ahead and look at the bottom one because as usual, you know, I like to make sure that I do the hard ones for you guys. So if we were looking at this, I'm going to start moving stuff around. So the 16 is going to stay on the top, right? But this C is negative, so I would move it to the bottom. So I'm going to come down here and I'm going to do the C squared here, right? Then I get to Z to the negative 11th, so then it would also be on the bottom. So Z, and we change it to a positive 11 because we moved it to the bottom, right? And then now I'm going to look at the ones at the bottom. 12, it's going to stay where it is, so I'm going to put the 12 there. Then I have a C to the 7th, so I could come down here and I'm going to do C to the 7th. And it stays where it is because it's a positive exponent. But then here's Z with a negative exponent. So I need to move it to the top and make it positive. So I now have Z to the 8th on the top. Again, notice we're making that exponent the opposite sign when we move it to a different place. So now we would be ready to simplify our solution. Well, now we have to go back and look at those product and quotient rules. Remember, if we multiply, we add. If we divide, we subtract. So if we're looking at this, I have a Z to the 8th on the top and a Z to the 11th on the bottom. So first things first, 16 divided by 12, that's going to give me a decimal. So I've got to reduce it as a fraction. So 16 over 12 would reduce to 4 over 3. And I'm going to have to kind of put a fraction bar in here because I guess I didn't put one in here and I'm not really sure why. And there we go. Scoot it over just a little. All right. And then, like we said, I have a Z to the 8th on the top and an 11 on the bottom. So if I go to put that in, I would have to subtract. So 8 minus 11 would be negative 3. So I would have Z to the negative 3, and it would go on the top right now. And we'll fix it in just a second, okay? Then we have these two C values that could go together because they have the same base. They are multiplied, so we would add. So 2 plus 7 would make C to the 9th. So then we would have to actually get another solution. We would have to finish reducing. And I'm basically just going to put in several spaces here. I'm going to do the same thing down here just so we can kind of get an idea. So now the 4 is going to stay here. The 3 is going to move or to stay where it is. The C to the 9th has a positive exponent, so it would stay. But now that Z to the negative 3 would have to go to the bottom and become positive. Not really sure where these little extra spaces came in. So our final answer for this one would end up being 4 over 3C to the 9th, Z to the 3rd. And I would try to put these equal signs in here. I guess this might be easier if I was left aligned here. And then I just space it. And I can do the same thing with this one so that we could line it up a little bit better. And that way I can space these out a little bit more so that you see the difference. So this is step 2. This would be your final answer. Okay. All right, so that's kind of it. That's negative exponents and the zero exponents. So it says combine everything that you have learned. So you're going to do your power to a power first. So you're going to distribute and multiply. Please do not forget this 2 goes to the 12. So you have to have 12 squared and then m squared squared. So remember we would multiply 2 times 2 and then we would have to do the 6 and the 2. So that's going to be the power to a power part. And we wouldn't really do anything with the bottom. Then you're going to do your product and quotient. So then you would end up subtracting. So you would get rid of the quotients, and then you would work with your negative powers from there. So you would start moving them to make them positive and putting them in the right places. Okay, so that's why I've labeled these steps for you. Okay, all right. I hope that gets you guys through. Here at the very end, I would just need you to do your normal knowledge check so that I can kind of get an idea of where you stand and how well you feel like you did on the negative exponents and the zero exponent rule. Remember, if you need any help, please make sure that you ask. You guys have a great day, and I will see you next time.